of Flux and Stuff production. How you doing? Today we're going to talk about how to build a high output EDF for your E-flite UMX MiG15. MiG15 is this super cool foot-long little rocket. It's pretty good out of the box, but I think we can do better. Stock, it produces 41 grams of thrust on the bench, but if we install this little baby, we can get 80 grams of thrust average. Put it right there, fits stock. You're going to need an external ESC. I show you how to build one of those in another video, but combine it with a 325 milliamp 65C battery and that ESC, you got a 91 gram or 98 gram chassis that can do this. 64.6. Vertical performance, awesome. Did you see that? Yeah, so that's pretty awesome stuff. Anyway, so all the bits we're going to need are here. I suggest you get a hobby knife. You're going to need a soldering iron. I use a 40 watt with a variable control on it. I also use a nice tip, ST7 I believe it's called. Pair of safety glasses whenever you test an EDF, wear some safety glasses. You're going to need the UMX 28mm EDF case by Nitocharged. You can get that on shapeways.com. You're going to need an AEO 27mm 7-blade EDF fan. You're going to need 3mm 1.4 motor screws. You're going to need 4 motor mount screws that come with the model. You're going to need some micro Phillips and flathead screwdrivers, some 280 grit sandpaper, a safety pin. You're going to need some bearing oil. The Parma bearing oil is what I use. You're going to need some phone safe CA, medium thick, thicker the better, some wire cutters. You're going to need some silver bearing solder. This is 015. You're going to need some helping hands to hold things. You're going to need some Kapton polyimide tape. It's high temperature and non-conductive. You're going to need a ruler. I like metal ones myself. You're going to need 1mm diameter heat shrink. Sorry about that. You're going to need these 3-pin connectors for the motor, and a Sharpie white paint pen, which is optional. I like it. You can see in the video description for a complete list of all the parts and links to where you can get it. So let's build this little baby, and this is how we do it. Okay, so the first step here is let's put some CA on. We're going to put just a tiny drop here. Now this material is going to absorb this CA quite nicely. And I'm going to use this guy here to spread it around. I've already got some on the back, so I'm not going to do the back. But I would put a little bit there, 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 and there, spread it. And then I would use a napkin or something to dab in there and make sure that I wasn't getting, I was cleaning off the surface and making sure that the surface in here was flat so the motor can mount cleanly. Okay, that's going to take a few minutes to dry, so we'll let that too. The material is kind of spongy. It absorbs the CA, which is just strange additive 3D printing stuff. Okay, next is the motor. Here I have a HPO6V2 stator. Obviously it doesn't have its bell on. The bell will just slips on the top through this bearing and this bearing. But this will serve for the purposes. Now you can see that this wire is coated in red. This is actually a copper wire that's been coated with ceramic coating to prevent it from shorting out against the other wires. But we need to trim our motor wire to be a certain length so that it fits perfectly in the chassis without creating any drama. The length that I'm suggesting that you cut your motor leads to is about 30 from the black stator out. I suggest it to be about 38 let's call it 40 millimeters. You need a little bit more play than I have on this one. This one's a little tight. So 40 millimeters. So we would measure our wire 40 millimeters. And these have already been trimmed. So boom, they're good. They'll probably be longer on yours when you get it. And then what you have to do is you have to heat up, and let me take a photo of what this looks like. A little close-up action. Okay, that's before. And what you're going to do is you're going to get the schmutz off your iron. And what you do is you're going to just touch it, and you'll just see it melt away. Blowing it away from you, and just watch carefully, and you can see it boil up. I'm going to do both sides just to make sure I got it good. Now, this is a 8,000 kV version of that motor, and we're using the 16,000 kV motor, version of that motor, and that means it's going to be the wires are going to be thicker, obviously, on the 16,000 kV, and you can see I've just cleanly burned that off. Okay, and that's a good enough photo. Okay, now that we've got it cleaned off, we can put a little bit of silver bearing solder on there. I'm going to turn the heat down because we don't need that hot to solder. We only need it at the maximum heat to melt the ceramic coating. Cool. Take another photo of that. Step 3, done. Okay, so now what we've done is we've successfully stripped, trimmed, stripped the coating, the ceramic coating with heat, and then soldered on some lead. Okay, so let's mount the motor plug onto, solder the motor plug onto the unit. So I have here a female side to this male side, which is going to go on the motor. It clicks in and put it in here, and I use this so that as the temperature rises on the plugs, the plastic, as it gets close to its melting point, has some structure with the other plug on it, and also these wires will help carry the heat away from the plastic and keep it all from deforming. So since I already have solder on my tips, all I have to do is touch this real quick, and they solder up so fast because they're very thin and they're gold plated and they transfer heat excellent. And I've got a nice hot iron here. So now all I'm going to do is just touch my wires. Get it nice and glossy. Next, and bend them a little bit. Get them to line up right where you want, and then just tap them. This one I think could use just a little bit of solder. I'll put it on the iron. Very nice. And the third one. Clean off your iron. There we go. Let's take a photo of what we got here. That's not what I wanted. Here we go. unplug it so there's no confusion. Okay, that's it. Next step. Let's lubricate our motor. Put a little drop there. And then if you sneak in from behind, you can see that there's a bearing in there, and I just tapped it on. And the bearing's right behind the brass, the copper wire, I'm sorry, on the shaft. And that is more than enough to kind of give this guy the lubrication he wants. Now, for whatever reason, if you need to remove the brass collar, you're going to need Loctite 609, and you'll do just you just do a dab on the table. You grab a pin or something, and you will just spread it right here. Now, this 609 is also not bad to put on the shaft instead of CA to create a little bit of buildup on the shaft if your fan blade is not sitting tight on there. So you see that fan blade is nice and tight, but I do have another fan blade here, an older one. It's been beat up, and it comes on and off too easily. So in that case, if this was my only fan blade and I was forced to use it, I would put a little of this 609 or a little bit of CA, just a tiny little bit, put it on there and let it dry, and even gently rub it off to clean it, so you don't want any real buildup. You don't want to be able to see that there's CA on there. Don't have to be able to see it. It'll be enough to create a tight enough tolerance for the fan blade. Alright, so that's my comment about this little brass ring. This brass ring keeps the bearing and the stator from flying off, and so you don't want it loose. Now, one of the things about installing, I'll bring it up now, is when you install this into the fan, you've got to be pressing on the back of the bell and the fan like so. Otherwise, if you just press here, what will happen is the pressure of the fan trying to get on the shaft will push the shaft off, will loosen the Loctite that's holding this brass bearing on, and the bell will separate from the stator, which is okay because the bell slips out, and you can put other bells on there. But you're now going to break the retainer here, and the bearing could slip off, especially at 80,000 RPM. Okay, so that's my comment on that. Cool. So let's put this all together. I think this has been long enough to dry here. So this is our shroud. We don't need this helping hands anymore. We don't need the bearings, oil, or the solder. Snips we can get rid of. Okay. We're going to need our motor mount screws. We have 4 of them. Okay, and I like to put on them before we get started their washers, because it makes life a whole lot easier. So we have 4 washers here. Okay, cool. And the last one. Now what we're going to do is we're going to put a little bit of Loctite on these guys, blue Loctite. I don't want them coming off. Little drop there. Okay, cool. We're going to take our Phillips. Now before we do this, I have marked this motor between the 2 holes like so. So there's one screw hole and another screw hole, and I put a little bit of white between the 2. The reason I did that will become evident in a second. Let me show you what I did here. It helps with installation. Okay, so when installing the motor wire, fold it back over the bell like so, and find the hole. This is the hole used to pop off the EDF fan, and align the motor wire with the hole at the top. That'll become obvious in a minute. And now that you have it in, the little white mark that I made right there is in between 2 motor holes, and it makes aligning easier. There's so many holes in there, it can be very hard to tell which way is up, so to speak. So I'm going to take my screw, Put it on my, just a dab of Loctite. Hand tighten it. Just a dab. Hand tighten. Little dab will do you. Hand tighten. Now that it's all hand tightened, I'm going to go 1, 2, 3, 4 in that order. Quarter turn past hand tighten. You do not want to over tighten this. The stator is made of aluminum and you can strip it. Quarter turn, hand tighten, quarter turn. That's it. The motor's on there and not going anywhere. The motor mount is more than strong enough to hold that. Don't worry about it. I've tested it a couple times already and it's plenty strong. Now let's just ensure that our motor wire is lined up with our hole. We can take our model and the hole aligns perfectly with the motor mounts. If you put it in the top, and you can see that's going to mount up perfectly. And just to check the fitment and the spacing and everything else, it's going to be perfect. Now the reason you want to cut these perfect is because if you have too much wire here, things get cockeyed. These wires in here get very hot, they get brittle, and you want to coat them a little bit with some heat shrink that I showed you, because they can touch this servo here. They can get kind of funny, and if they're too long, you're going to have to wrap them, and they don't wrap well because they're very thick, and they'll touch the canopy at the top. Better to go through the effort to strip them down, cut them to length, and put them in there perfectly. Okay, hope that you follow that step. That step's important for a clean install. Okay, so we've got all that on there. Let me just test which one of these. Oh, this is the beat up one, I think. Oh, no, that's not the beat up one. That's the brand new one. This is the beat up one. Yeah, it fits nice and smooth. We don't want that one. We want this one. Okay, so you can see this is a long shaft HPO6 V2. This one's for the AEO 28 millimeter EDF that you can buy. I upgraded them with using this motor. Had this shaft made custom. Alright, but this is using the stock motor with the stock shaft. This is 12 millimeters in the air. This is 6 millimeters in the air. Okay, so now that we have our thing here, let's put this motor together. So what I like to do is you'll see that if you look through here, you can see the motor mount screw is there. And the problem is that it's very hard to get the screwdriver in there to pop this off because that screw's in the way. If you push this too far down, you will make it impossible for it to turn because it will touch these screws or that brass ring, and well, anyways, the point is it won't be happy. So you don't want to go that far down. So the trick is to push. Now this is very important. You have to push the back of the motor with your finger while holding the shroud like so, while pushing this on, but not too far. Get it lined up on there. Push it just a tiny bit. I like to put this screwdriver in there, if you will, and using my hands and very careful pressure. That's it. Okay, now note the spacing here. There's very little, maybe 1 millimeter between the top of the blade and the exit of the... See, I went too far with that. I pushed it too far down. Now I have to fight to get this thing out. Now I can barely fit this screwdriver, this tiny screwdriver in there, and I have to play and I have to flex, and this is where you could possibly break your motor casing, because it's not designed for any type of manipulation like this. Oh, felt it come off. Okay, that works. Still not happy though. Okay, put the screwdriver back in. Now I'm holding from behind and I'm squeezing in the front. There you go, I got it. You can see there's practically exactly 1 mil there. Yeah, it's 1 millimeter. So 1 millimeter gap between the top of the blade and the exit, the top of the shroud. 1 millimeter. If you got 1 millimeter, you hit it right on the money. Okay, cool. We are done with our EDF. Let's install it. Okay, let's get our model. So now, it's all ready to go. Spins nicely with the finger. It's gonna pop the motor plug through the top. Straighten it out a little bit first. Get it in. Cool. Let's check the fitment and alignment. Now we're going to take our 4 motor mount screws. Just a quarter turn past hand tighten. Do not over tighten these. You notice I'm using the packaging of from the shipping container package for a mount to hold everything together. Works out super good. Okay, normally you should put a lower half in there to hold this together, but we're not going to be doing anything stressful, so this will be fine. Okay, so now it's time to connect the motor and the ESC, and you just push it together until you feel it snap, and there you go. I'm going to show you a picture of that. Okay, that's fine. Okay, piece of Kapton tape. We got to tape that because I have had that come loose in flight, and don't want that. So a little piece of Kapton. The reason I'm using Kapton here is because it gets really hot. It's carrying 13, 14, 15 amps max, and those wires get super duper hot. Okay. I'm going to lift it up a little bit, get this Kapton in there, slip it under from underneath. Okay, before I can put the Kapton though, I got to make sure that this plug has not changed orientation, which it has in front of me. And I'm going to use 2 pieces of a tool. I'll squeeze it together. You can use your nails if you want. And then I'm going to press it. I'm going to fold it over. Now, this may be a function of the fact that I just unplug and plug this thing a lot, and that this particular plug has gotten a little bit beat up, so to speak. Or it may be a function of that I don't have enough lead wire, which is why I told you to cut yours a little bit longer than mine. It's because this one's a little bit of a tight fit. Okay, though, that's there, and that's not going anywhere. Okay, cool. That's it. The last step is to test the rotation of the fan. Otherwise, you can change the pin, but I know it's perfect because I've tested it before. Let's get our model. We're not going full throttle here. Don't look at the fan blade. Always be behind it. Never have your hand in front of it or anything like that. Just going to hold the model in place, and we're just going to feel for some flow coming out the back. And that's it. We are done. That works for me, guys. All right, we're done here. Unplug it. Turn off our remote. There you go. You're done. You've installed a Nitocharged shroud on an XP12A with a HP06 V2 16,000 kV. Good for about 80 to 90 grams of thrust. All right, guys. Have a nice day. Be well. Good luck.